Hello all, let's start section 3.3. Your 3.3 is about measures of variation, correct? There is another way that you can calculate the center of your data, which we call it variation. Now, what is variation first? Variation means how the data is spread. That's it. Very simple definition. How the data is spread, we call it variation. To explain more why we are using variation, how we can calculate, let's focus on this example. You will see the difference why. Correct? Then I'll give you some properties, then we give you some formula, and easily you can understand. Correct? For example, let's consider a bank. Correct? Let's go to a bank. We want to pay some money in the bank and we have to wait in the line, correct? Here I will write bank lines, correct? Let's focus on this example. I will give you three banks: bank number 1, bank number 2, and bank number 3. And here I will write time in minutes, correct? All of us, we have this experience. Sometimes we are going to a bank and you have to wait in the line to go for your turn and to go to do your work, right? To pay money or to take money out of your account, whatever you are going to a bank. In bank 1, they have a good manager. He is standing by the lines and 3 people are waiting to go to the line. He's helping the people, says, sir, you go to this, sir, you go to this line, sir, you go to this line, correct? The time that people are waiting is for each one of them is 6 minutes, equal. You wait 6 minutes, then the manager tells you, sir, that's empty, go there. Sir, that window is free, you can go there. The time to wait for each individual, there are 3 people there, it's 6 minutes. There is another type. The first person is waiting 4 minutes, then the second person waiting 7 minutes, and the third person is waiting 7 minutes. Correct? There are 3 lines, you go there. The last type is our typical kind of bank setup that we go. There are, it's like mainly like grocery stores. You choose a line to go, correct? The first person is choosing a line and he waits 1 minute and he goes to the window. The second person, 3 minutes wait, then go to window. Last person, 14 minutes wait, then it comes up. Believe me, every time that I'm going to a grocery store, I choose the kind of shortest lane and I go there to pay because I'm in rush, and believe me, every time I'm waiting more than other people. It happens to me, correct? 14 minutes wait. Now, if I ask you here to find the mean for each individual, bank 1, bank 2, bank 3, for example, we know that x bar equals the sum of the x's over n, right? Sum of the x's, 6 plus 6 plus 6 for bank 1 gives you 18. Over 3, number of data that we have, 3, gives you 6. It means your mean, I'm sorry, the average time that you are waiting in bank 1 will be 6 minutes for each one. If you calculate bank 2, x bar, you will see again you end up with 6 minutes. Bank 3, again the mean is 6 minutes. There is no difference, but it's not fair. One person waited 14 minutes and the other person is just waited 1 minute, and you just find the average or the mean. All of them is equal, 6 minutes, 6 minutes, 6 minutes. But here I can say there should be another way to calculate the center of your data, which we call it variation. Now there are ways to measure variation. Which ways? I will explain one by one. The first way, we call it finding range. When you find range, that's the easiest way to calculate variation. Correct? It's the easiest way to calculate variation. What's the formula? You take your maximum value and you subtract the minimum value, the mean value. It gives you the range. That easy. Look, it's easy to calculate or to find. Correct? To calculate, to find. But there is a problem. Let's discuss the problem. It's really easy to calculate the range of a given data set. For example, you have a data set consists of like 100 items in it. Your lowest item, I will do an example here. For example, look at this data set. 2, 3, 4, 5, 9, 11, 24, 36, 38, 210. If I want to find the range here, my maximum value, which is 210, minus the smallest value, 2, it gives me the range, 208. But what happened? I didn't focus on all other data that I have here. That's the bad part. You see, I skipped all of these. If this number is changing, the max, it changes the range without focusing on the other data. That's the bad part. Now I can say it's easy to find, but does not consider all values. But does not consider all values. This is the bad part if you want to just find the range of a data set. It's really easy to calculate, but it does not consider all the values. Correct? The second type, or the second way to calculate variation, we call it standard deviation. Standard deviation. It's another way to calculate the variation. Correct? What does it mean, a standard deviation? What the standard deviation actually does, measures the average distance of the data values from the mean. Believe me, this definition is really important. I see a lot of students, oh, let's find a standard deviation. I see classes, oh, we work on a standard deviation. And if you ask them, what does it mean? They don't know what's a standard deviation. You have to know the definition. Actually, standard deviation measures the distance of your data from the mean. How far your data is separated from the mean. We are looking to that distance, correct? For example, if I draw here a line like this, if this is your mean, I'll talk about just a sample. For example, here is your mean equals to 6, correct? How far your data, for example, 14, right? How far this 14 is from the mean in the bank example, or how far 3 is from the mean. It's really good thing to calculate the variation, correct? What is the standard deviation? One more time. Standard deviation measures the average distance of the data values from what? From the mean, correct? Now, some easy properties. I can call here properties. Property number 1, or star number 1. Never negative. Let's translate why. Standard deviation cannot be negative, never negative. You can write a good sentence, or you can read my slides, or you can read your book. They have a better English language. Standard deviation cannot be negative. Why? When I'm telling you standard deviation calculates or measures how far a data, this is for example my data, this is my x, data value, we name it x. How far this x is from the mean, I'm talking about distance, correct? Those of you that you had few classes of mathematics, or even without having a class of mathematics, we know this much, that the distance cannot be negative, correct? Distance cannot be negative. That's why standard deviation cannot be negative, correct? Property number 2. Never zero, never can be zero unless all entries are the same. Standard deviation cannot be zero. Data has definitely a distance from the mean. The only special case that your standard deviation can be zero is, in this example, the first bank. All your data set is the same, 6, 6, 6. You see, your mean is 6. If I subtract x from it, another 6, 6 minus 6 gives you 0. Standard deviation cannot be 0. The only case that the standard deviation becomes 0 is if all your data is the same. Correct? Characteristic number 3, or property number 3, greatly affected, let's say it this way, greatly affected by outliers. Greatly affected by outliers. Correct? In the example that I did here, like this data set 2, 3, 4, 5, 6, 9, if you find the mean here, 210 is an outlier for us. This data is too far from 38 or from 2, right? The mean will be somewhere here around maybe 24 or something, around 20s. The mean is there, but 210 is too far from that, correct? Then, and we call it outlier, correct? Such a data, we call it outlier. You saw even in the graph the other day that I explained it, that sometimes your graph is like this, correct? Has a tail on the right or on the left, which we call this outliers. The data that's here, we call them outliers. Standard deviation can be greatly affected by outliers. Correct? Now, let's talk about the formula. I will write here sample standard deviation. Sample standard deviation. After this, I will use like this standard deviation. Please do not, I will write STD. I know I shouldn't, but I mean by this standard, correct? Standard deviation. Don't see it like in other languages, like in other translation. For me, it's a standard deviation. For most of the professors that we teach, because we don't want to write standard deviation every time, we just maybe write in our examples like this, correct? It means standard deviation. Okay, first notation, or let me write this way. Sample standard deviation denoted by lowercase s. Correct? If you are dealing with sample. Sample standard deviation denoted by s. Now, I can say s equals. If I ask you this question, for example, here is 2, here is 8. How much is this distance between 8 and 2? Immediately you will answer, I will subtract from 8, 2, it gives me what? 6. Now, based on the definition, this is your mean, x bar, and this is your data value, x, correct? To find the distance, definitely you will say x minus what? X bar. Okay, x minus x bar. Remember, sometimes this mean will be greater than your data value. What happens if your mean is greater than your data value? You end up with negative number, correct? Because the standard deviation cannot be negative. Of course, this formula has a calculus reason behind that we create, but I cannot explain to you here the calculus of it the actual way. I'm trying to explain to you why you have a square in your formula. X minus x bar, then square it. The only reason to square it is somehow to change the negatives to what? To positive. And also, it's the sum of them, right? Now, When I talk about standard deviation, then the sum of this distance, x minus x bar, all square, because we are saying we are looking to the average distance, then divide by our number of our data, but here minus 1. To remove back this square, this formula has a square root like this. This is the formula to find the standard deviation of a data set. S equals square root of sum of x minus x bar all square over n minus 1. There is another easier formula for this. S equals square root of n times sum of x square minus sum of x square like this. I will explain it later what is the difference between these two. Over n times n minus 1. Both of them, if you solve a problem with this formula or if you solve a problem with this formula, the standard deviation will be the same. What is the difference between these two formulas? Why we have two different formulas to just find the standard deviation? In formula number 1, you see I'm using the mean. I have x bar in it. And formula number 2, we are not even using the mean. Sometimes it's easier if they give you the mean of a data set, use it. Or if your data set is too small, use the first formula. If the mean is not given and you are really dealing with a big data set, then it's better to use the second formula. Correct? Still, you can find the standard deviation of a data set. I'll do one example here for you. Example number 1. I tried to do few. Find the standard deviation. Find the standard deviation for the wait time. For the wait time. Again, it's the same bank example, but I'll go to bank 3. Your data is 1. The time for waiting was 1 minute, 3 minutes, and 14 minutes. Correct? Now I want to find the standard deviation. In your book, immediately they drop everything in a formula, but in my style of teaching, you see, I will create a table for you to make your life easier. It's up to you that you follow the kind of rule or the method that you use in your book, or you follow my method how to solve a problem. What I do here, I will create columns first to make it easy for me. First, I want to find x minus x bar. We already calculate the mean for this. If not, you can calculate the mean x bar equals the sum of these 1 plus 3 plus 14 divide by number of them, which is 3, which gives you 6. Correct? Now, to create the second column, the first one will be 6 minus 1. Oh, sorry, 1 minus 6. 1 minus 6, which gives you negative 5. The second one will be 3 minus 6, which gives you negative 3. The third one will be 14 minus 6, which gives you negative 8. Correct? 14 minus 6, positive 8. In the next column, because you see here you got negative, I'll find x minus x bar square. It means just square these numbers, the result. Negative 5 squared. Negative 5 squared gives you 25 positive. Negative 3 squared gives you 9. Positive 8 squared gives you 64. Correct? After you are done with this part, because your formula is designed this way, you see the formula that you have in method 1 or in using formula 1. Your formula is square s equals the square root of sum of x minus x bar squared over n minus 1. I need the sum of these. Sum of x minus x bar squared is actually adding these these three numbers, 25 plus 9 plus 64, which gives you how much? If you add them, 98. Now, plug in this number in the formula, it's easy to calculate. S equals a square root of sum of this, which is 98, over n minus 1. Your n is 3, right? 3 minus 1. Oh, sorry, not 31. 3 minus 1. Which is equal square root of 98 over 2, which gives you a square root of 49, and a square root of 49 is 7. That means your standard deviation for the bank 3 is 7 minutes, or the distance is 7. Correct? And method 2, this was method 1 using formula 2. And formula 2, you need to find two things using formula 2. You need your x, which is 1, 3, and 14. You need to find the x square, which gives you 1, 9, 14 square is 196. If you square 14, it gives you 196. And you need to find the sum of x square. Sum of x square gives you 206. Correct? And the sum of the x's gives you 18. Your formula 2 was s equals square root of, what was like the actual formula, and sum of x squared minus parentheses sum of x all squared over n times n minus 1. You see there is a difference between two. You said, oh wow, they are the same. Sum of x squared, sum of x squared, all squared. Here, you are squaring your data, then adding. Here, you are adding your data, then square. The second one is this. The first one is this. That's the difference, correct? Then s equals a square root of n, which is 3, times sum of x squared. Sum of x squared is 206, correct? Times 206 minus sum of x squared. It means 18 squared over n. 3 times n minus 1 gives you 2. And if you simplify, s equals a square root of 3 times 206 gives you 618. Minus 18 square gives you 324. Over 3 times 2 gives you 6. Simplifying that, you end up with a square root of 49 again, which is what? 7. You see, in both cases, you end up using which method, which formula, you end up with 7. And this one, in the method 1, I needed x bar. That's why I calculated x bar, the mean of the data set. And formula 2, I don't need the mean. Correct? Let's go to bank 2, right? Example number 2. Find standard deviation of 4, 7, 7. That was bank 2, right? The wait time for someone was 4 minutes, the other 7 minutes. Correct? I will do this one using formula 2. I don't want to calculate the mean, for example. I'm too lazy to calculate the mean. Here is my x, 4, 7, 7, and the sum of x equals 7 plus 7 plus 4 gives you 18. Here I will calculate x squared, which gives me 16, 49, 49, and the sum of x squared equals, I think, 114, 114. My formula, s equals square root of n sum of x squared minus sum of x all square over n times n minus 1. Plug in the numbers. S equals square root of 3 times sum of x squared 114, not 144, 114. My pen. 114 minus 18 squared over 3 times 2. S equals, if you multiply 3 with 114, it gives you 342. Minus 18 squared is 324 over 6, which you end up with a square root of 3, and a square root of 3 is approximately 1.73. Do you see this? 1.73 standard deviation. In this problem, your standard deviation was 7. Now you can see how far is the wait time from each other. Here is 1.3, there is 7. It's a huge difference. Correct? This was another example of the finding standard deviation. I will stop the lecture here because in the next one I'll give you actually, let me give you this, then I can stop the lecture. The next one is finding standard deviation for population, for a population. Up to now, the two formulas that I gave it to you, it was finding the standard deviation for a sample. For the population, it's basically the same, just the notation is changing. First, let me put here notation. For population, standard deviation, we use this letter. We draw a circle, then draw a line here. The actual one is like this, but no one is going to do this. Correct? It's so difficult to draw it. Just a circle, a line in the top, like a cannon. It's the lowercase sigma. It's a Greek letter. Correct? This is the lowercase sigma. For us in this book, it means standard deviation for a population. Then sigma equals, still you have the square root, x minus, instead of x bar, what is the symbol for the mean of a population? We use mu, right? A square over capital N, not minus 1, only N. That's the only difference when you calculate standard deviation of a population. Correct? Now, I'll stop the lecture here, the part 1 of section 3.3, and part 2, I will talk about variance. Variance of a sample and population. I will cover that one in part 2. It's not that kind of long, finding the variance. There is no new formula for it. Actually, you are using the standard deviation formula, and you can find the variance. It's not a long lecture, but in that lecture also I will talk about more properties of a standard deviation. There are some more properties, and also we will talk about finding the what we call it a rule to know how much data is actually we have around our mean, correct? Anyway, I'll stop the lecture here. See you all in part 2 of section 3.3.